Hi. So, as some of you might be aware, I've been working on this binary clock project for the last few weeks, and I thought it was probably a good time to do a little video demonstration of what these things are and what they do besides tell time, how they work and whatnot. It's come together pretty well as a project. I'm actually quite happy with it. Basically, the idea was to get a bunch of RGB, red, green, blue LEDs on a board and have it tell you the time in binary. I built a kit probably close to 20 years ago that just used some old red-green LEDs where the diodes are inverted and connected backwards. So basically, it would only be red or green. These are red, green, blue LEDs, so they can basically make any color. And what I've done is got some software on here that obviously tells you the time, but it has the ability to gradually change the colors over the course of the day, and it can cycle through not just the time, but also the date and the temperature as well. Basically, I've got two different versions of it up on my GitHub. There's a kind of a version 2x and a version 3x. The difference between the two is that the version 3x one is an SPI or SPI only version of it. The 2.x versions have some I2C peripherals, which I'll explain in a second. I just eliminated that from the 3.x version boards because it's a little bit easier to just have one rather than dealing with both. So in any event, the lower one and this one here with the jumbo LEDs on it, which I just put together today, is really cool. These are the version 3x, the one over here is a version 2x. In terms of the functionality, they're identical. It's really just the hardware that's a little bit different. So anyway, the way these things work is when they power on, if the time is set, it just goes straight to the time. There are touch keys along the bottom, and they are labeled A, B, C, E, D, and U. And E is kind of the enter-exit key, so if you hit this, it brings you into this menu where you get just a number on the left side of the display. And what I did was, on the back of the board, you can see what all the different menu items are. And then also there are some options bits, which I'll show you in a second, where we can set some different things. Those are just printed above or below the LED on the back, so when you need to reference it, it's right there for you. So anyway, option 5 happens to be where you can set the time. So basically hours, minutes, and then seconds. And up and down work as you might expect. Up goes up, down goes down. If you keep your finger on there, it'll advance a little more quickly rather than constantly tapping it. So if you're trying to get somewhere, it's a little easier. The A key applies the time that you've chosen. If you just hit E again, it'll just take you back to the menu without saving it or applying it. So you can kind of get in and out of different menu options without necessarily affecting things right away. So we can set the time, we can set the date. It has a little counter mode. So if you just want to count seconds, it can do that. It can actually count up or down. If you hit the D key, it'll begin counting down. And it's just a real simple seconds counter, nothing special. The A key starts, the B key stops, the C key clears it. And you can see when it gets to 0, it wraps around. You can also, if you stop it and clear it, you can hold one of these down to advance. So maybe I want 27 seconds, 26, I can start it. It'll count down to 0. So, you know, use it how you will. It's just, it made sense for it to be there, I suppose. Anyway, in terms of options that you can set, there are these bits, kind of flags that you can just toggle on or off, and they do different things. So it has a BCD mode or binary mode. So depending on how you want to look at the display, You can set it to binary coded decimal, which personally I find a little easier to read, or you can set it to just straight up binary. So it'll show you the time, hours, minutes, seconds, year, month, day, based on that. That setting is global, so if you toggle it on or off, it affects not just the time display, but also the date display, the temperature display, all of the menu options, and so on and so forth. So it reaches through to everything. It's got a 12 or 24 hour mode, so for those of us, pretty much anyone outside the United States, you probably have it in 24-hour mode. There is a little status LED here, and when it's displaying the time, you can configure that as a PM indicator, and it'll actually change the color of that status LED with the rest of the display. So you can toggle that on or off if you have it in 12-hour mode. Sometimes it's handy to have that PM indicator. It has an hourly chime. It will actually beep the time in binary. So if it's 2 o'clock, you'll get a low tone and then a high tone. If it's 5 o'clock, you'll get a high tone, a low tone, and then another high tone. So you can actually hear the time in binary. Really clever, I know. It does have the ability to adjust itself for daylight savings time, so if you live in an area where they do that, it has that ability. You have the ability to set the month in which that happens, the hour in which that happens, and then the day in which that happens based on the week. So like if it's the second Sunday, you can set it to do that. So like in the US, we do the first Sunday in November, the second Sunday in March is when it switches. So you can adjust all of that if you do something different in your area. It can display the temperature in Fahrenheit or Celsius. You can toggle the color fading on or off, which I'll talk about in a second. And then it also has a phototransistor on the front right here, which allows it to sense the ambient light in the room. And if we kind of cover that, it's sort of bright in here, but you can see the display will actually dim, so that if you keep it on your nightstand, it's not blinding you all night long, which I think is really cool. So anyway, so those are some of the different options that it has. It has the ability to store 8 different times, or time slots is kind of what I've been calling them. So basically what you can do is it works sort of like an alarm clock, where you set a time and the alarm can sound at that time. In addition to just being an alarm, which it actually doesn't have to be an alarm, you can set a color, a desired color at that particular time. So if I want red LEDs for 0 and green LEDs for 1 at 3 o'clock, you can set that. Any one of those 8 time slots can be an alarm, so it'll actually sound the beeper for you. It can define a color, and it can also cause the display to blink on and off. So at a given time, you can have any one or any combination of those 3 things happening, which is neat because with this color fading option that I mentioned here, it can gradually change the color from one time slot to the next. So what I've done by default in the software is every 3 hours is another one of those slots. They're all enabled to set a color, and so the clock will actually gradually change colors for you all day. I think it's really cool. It was something that I just kind of thought would be neat, put it into code and watched it happen, and was like, oh, awesome, this works really well. So you can also customize those colors. So there's actually a color picker in here. If we go to the right option, and you can, there's obviously a set of default colors defined, but you can set your own. So there's a color picker here, and basically what this does is I have the ability to set, you can see all the way on the left, foreground or background, or basically 1 or 0. So that's a color attribute, red, green, or blue for 1, red, green, or blue for 0. This is an interval by which I'll adjust that particular color attribute. And then I can do up or down to set that. So you can see as I'm adjusting this, the colors are actually changing on those LEDs on the right. So that's kind of my sort of preview window, if you will, so I can see the color that I'm generating. You can do that for every single one of those 8 time slots, in addition to defining a set of colors that it uses for the date and for the temperature. So you can easily distinguish exactly what's on the display, potentially, by the colors. So it has a lot of flexibility in that regard. They're RGB LEDs, you know, you might as well use them. It has the ability, and you may be able to see it in the video, to fade the colors, fade the bits in and out. So you can kind of see it doesn't abruptly transition. The colors, as the LEDs transition, they sort of fade. All the LEDs are connected to PWM drivers, so they can all dim, they can be any intensity. They're 12-bit PWM drivers, and I didn't strip them down to 4 bits or 8 bits or anything. So you get the full range of intensities, and even at very low intensities, the transitioning is very smooth, which is something I was kind of striving for and was able to do it. So the drivers that are on here are these TLC 5947s. They're not really an SPI driver, but they work well with SPI, so there you have it. Basically, each driver is one set of color elements. So this is the red driver, the green driver, and the blue driver. The reason I did that rather than just tying every LED to every driver in sequence is because you have the ability with these things, they're constant current drivers. So if you tweak some of the resistor values down just below them, you can adjust the current for each one of the color elements, red or green or blue. And so you can actually achieve a little bit of color correction that way based on the LEDs that you're using. If I just ran red, green, and blue into the sequential inputs on the chips, you wouldn't be able to do that. So that was another little thing that worked out really well. In terms of the hardware, it's an STM32F0 microcontroller, 48-pin one. It's using the SPI interface to talk to the drivers, and on the version 3 also talk to the external time clock and temperature sensor if you choose to put those on the board, which you don't have to. I'll get to that in a second. On the I2C one, it uses I2C to communicate between the microcontroller and the external chips, again, if you choose to put them on the board. The STM32 microcontrollers have a real time clock and calendar built into them, and it works really well. The caveat is it might drift a little. I put a 32 kilohertz oscillator on here so that it has the dedicated clock, and it also has a backup battery on here, so if you unplug it, when you plug it back in, it remembers the time and can go right back to it. Since this oscillator isn't super precision, it's pretty good, don't get me wrong, but it may drift by a few minutes over the course of the year, maybe even an hour or two, depending on how unlucky you are. If that's okay for you, that's really all you need. The STM32 microprocessor's got a temperature sensor and the time clock all built in, so it can function with just that. If you want something a little more precision, you can put on these boards one of these DS32 3.1 or 3.4, depending on which version you build. These are designed to drift less than 2 minutes per year. They're very accurate. They've got a temperature compensated oscillator in them. And basically what happens is if when the thing starts up, it tries to talk to this chip. If it sees it on the board, it uses this for the time rather than the internal clock on the STM32. It also has a temperature sensor. That's this little 4-pin chip here. That is a DS1722. It is also an SPI temperature sensor. I have a footprint on here for an LM74, so you could use that as an alternative. You use one or the other, not both. Again, when it powers on, it checks to see if that chip is there. If it finds it, it uses it. If not, it'll use the temperature sensor on the DS3230X. If you've installed it, if it doesn't find that, then it uses the temperature sensor on the STM32. So there's a little flexibility in the design in terms of what you populate the board with. You don't have to put all these external things on here. It'll actually work without them, which saves you probably about $10. So that's not a bad thing. Other than that, it's got the standard 6-pin serial interface. I also put an RS485 transceiver on here. I was going to use it to receive DMX512 so that you could play with these lights, play with the LEDs with the lighting controller. I haven't written that to software just yet, but we'll get there. You could also use it for synchronizing clocks or something else if you wanted to connect several of them together, and I don't know. But it's there. It's also optional. The serial thing you kind of need to program it. The STM32s ship with a bootloader already flashed on the chip. So all you need to do is take the boot 0 pin. I think you tie it to VCC. Maybe ground. I don't remember. Anyway, you pull it one way or the other, you reset the chip, and it invokes the bootloader. Then you can take it off, flash the code onto it, and you have yourself a nice clock after you solder all these things, which isn't really that bad. The one challenge with the TLC 5947s is they have a thermal pad on the back. It's under the chip, you can't see it. So if you don't have hot air to solder this thing, I'm not really sure how you'd get to that. Food for thought. If you're planning on building one of these, you might want to either get yourself a hot air station or make friends with someone who does have one, at least for that reason. The chip does use that as a thermal relief. These chips, if you turn the current drive all the way up on them, they get pretty hot. Hot enough to burn you. So you definitely want to make sure that that's soldered correctly. If you use them at a really low power, it's probably not an issue, but in any event, I think that's about it. This turned out really well. I'm really happy with this. It works great. The clock is very accurate, especially with the external RTC on there. The colors are really pretty, and this one with the giant LEDs, which I thought I was going to not like at all, I actually love it. It's really cool looking. The big LEDs are just really awesome. I'm quite pleased with that. Maybe I'll build another one. I have a stack of boards here. So anyway, that's about it. If you have any questions, feel free to reach out or leave a comment. I'll try to pay attention and respond as I'm able. There's still more to come with the software, but it's very usable right now, so I would encourage you to look at the designs and maybe throw one together yourself. Anyway, thanks for watching. I hope you enjoyed, and again, leave some comments if you like.